Hello everyone. This lesson is for solving quadratic equations, and we've learned about many different ways of solving equations, and specifically quadratic equations. But there are some methods that work better or are easier than others for getting to what the values for x actually equal. The quadratic formula will work for everything, but it's not always the fastest method. Sometimes you can simply solve by factoring the trinomial to two binomial pairs, or it would be easier to isolate an x squared term and solve in that way. So it helps to review what the different methods are for solving quadratic equations. The first method has to do with perfect square equations. So if you've got a perfect square on each side of the equation, you can take the square root of each side and then um, solve to find your two values of x. So in this first example, if I had x plus 5 squared equal to 49, you could take the square root of each side first and then solve for your two values of x. Another example with the perfect square factoring pattern is if you've only got an x squared term, you can isolate that x squared term by dividing by this 5 on each side and then take the square root of each side to find your answer. We've also talked about factoring, where you've got a trinomial that factors easily. So for example, x squared plus 5x plus 6 equals 0. This trinomial would factor easily to x plus 3, x plus 2, and you can see, think of it as using the FOIL method but backwards. So first times the first gets you x squared. The outside 2, so 2x plus the inside 2, 3x, that's how we get that 5x. And then 3 times 2, that's how we're getting that 6x. But it's helpful to have your equation in standard form first, and then try to factor, so have it set equal to 0. And for it to factor easily, when you calculate out the discriminant, so using b squared minus 4ac, when you calculate it out, it should come out to be a perfect square. If it does not come out to be a perfect square, then you wouldn't want to use factoring to solve. Another method we've talked about is completing the square, where you're adding b divided by 2 squared to each side. Your equation you're looking for should be in x squared plus bx equals c form. So notice the difference from standard form. It's got the c term on this side of the equal sign. And the coefficient of x squared term should be 1. If this term doesn't have 1 with it, then you wouldn't want to use completing the square. And the other thing to look for completing the square, the value of b should be even. So the coefficient of x squared term should be 1 and b should be even. If that's the case and it's in this form of an equation, then you'd want to finish solving. The easiest way would be by completing the square. And this is where you add b divided by 2 squared on each side of the equation. And then the last method that we've talked about is with the quadratic formula. So you want your equation to be in standard form. So ax squared plus bx plus c set equal to 0. And always start off by calculating out that perfect square, or calculating out the discriminant to see if it is a perfect square or not. My window doesn't go down far enough, but here we've got the quadratic formula. Oh, there we go. The quadratic formula, so x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So make sure you've got the quadratic formula in your notes. And just a helpful tip, we've learned about the discriminant and what it tells us. When you calculate out the discriminant, it's going to tell you if you're going to have two rational solutions, so integer values most often, or two irrational solutions. It'll also tell you if there's no solution, or if there's exactly one solution. So it helps to kind of use that discriminant as a quick check to kind of eliminate some of the answer choices for what the best method is going to be for solving. And I have always advised that the best method is actually the method that works most often for you. So if you're having a difficult time solving the quadratic equations, but you know how to use the quadratic formula, then use the quadratic formula. If you're really good at factoring and you want to try factoring first, then try factoring first. But the quadratic formula will definitely work for every single one as long as it is in standard form. But this main lesson in the course is really wanting you to try to identify what the easiest method would be for a certain trinomial. And to kind of help you think about the different patterns, what's going to be the easiest method, I've created this quadratic equations flow chart. So kind of treat it as a way to answer yes or no for the different categories. So when you're first given a trinomial that they want you to factor or to solve, if you start off by checking to see if it factors with perfect squares factoring pattern, then you'll be able to kind of go through the rest of this to see which method they would select as the easiest method. So if it is perfect square factoring, so yes, it's perfect square factoring, then you would go this route. And to determine if it is in a perfect square factoring pattern, it should be in the form a squared plus 2ab plus b squared. So it could factor to a plus b squared. Or the other component is if the equation only has an x squared term, then you'd want to isolate that x squared term and solve by taking the square root. That would be the perfect squares pattern. So if it's yes, you would go this route and you choose perfect squares pattern. If it's not in that path, then you would want to follow the other direction. So no, then you want to check, is my equation in standard form? So yes or no, my equation, if it is in standard form, then you want to calculate the discriminant. So b squared minus 4ac. So if your equation is in standard form, calculate the discriminant. If it's a perfect square, then the best method is factoring. If it's not a perfect square, then you'd want to use the quadratic formula. So check for standard form. In standard form, then calculate the discriminant and go from there. If it's not in standard form, then you want to check to see if you can complete the square. So again, the guidelines for completing the square, the x squared term should be 1 and b needs to be even. If both of those two categories are met, then you can solve by completing the square, and that's where you add b over 2 squared on each side. If it's not, then rewrite the equation into standard form, calculate out your discriminant, and then see if it's a perfect square, you'll factor it. If it's not a perfect square, then you'll want to use the quadratic formula. And this flow chart is really just set up for you to determine what the right method is, or choosing the easiest method as the quiz wants you to select. But when you're actually solving it, you can choose whichever method you want. So let's take a look at how this works. So for the first one, what would be the best method? So I have 14x squared minus 56 equals 0. So we want to check for factoring squares pattern. Is it in the form of a squared plus 2ab plus b squared, or factors to a binomial squared? No, I don't have an x term in here, but the other part is if the equation has only an x squared term, then we want to choose perfect squares pattern. In this one, I see this one only has an x squared term. So if I were to actually go through and solve this, so get the x squared term by itself by adding 56 and then dividing by 14, I would have x squared equals 4. And then you could take the square root of each side and have x equals plus or minus 2. So this method, perfect squares factoring pattern, would be the best method that you could use to solve it, mainly just because it's the quickest method. Another example, I have x squared plus 4x equals 6. So starting off here, check for perfect squares factoring pattern. It's not in the perfect squares factoring pattern, and I don't only have an x squared term, so I would want to follow this path. So then check the equation is in standard form. My equation here is not in standard form because standard form looks like ax squared ax squared plus bx plus c equals 0. So since it's not in standard form, I would continue down this path. And now I want to check to see if I could complete the square. So it has to have a coefficient of 1 and b needs to be even. I have a coefficient of 1 and b is even. So this one would be completing the square would be the easiest method. And to see how to solve using completing the square, you would start off by adding b divided by 2 squared to each side. So looking at our example here, our b term is 4. So 4 divided by 2 squared. 4 divided by 2 simplifies to 2 squared. So you're adding 2 squared to each side, which actually equals 4. So we added 4 to each side. This trinomial can factor to a perfect square factoring pattern. So x plus 2 squared equals 10. And then you would just take the square root of each side. So x plus 2 equals plus or minus the square root of 10. And then you'd have your two possible solutions from this plus or minus. Whoops, I didn't actually want to write on there. From that plus or minus the square root of 10. Another quick example, which would be the best method. So again, going through, it's not in perfect squares pattern, so I'd go this route. It's in standard form. So yes, it's in standard form, so I would go this route. If I calculate out the discriminant, so this is my next step to decide if factoring or quadratic formula would be the best method. If I calculate out the discriminant of this equation, so b squared minus 4ac, b is 10, so 10 squared minus 4 times 3 times minus 5, you end up with 100 plus 60. It's positive, but it's not a perfect square. So this one you'd want to use the quadratic formula to finish solving. So going through using the quadratic formula, plugging in a, b, and c. We already calculated the discriminant, so replace that with 160. We end up with decimal values because 160 is not a perfect square. And then you have approximate answers because we're rounding. Finally, one last example, x squared minus 8x plus 15 equals 0. So again, check for perfect squares pattern. This is not a perfect square, so I know it's not over here. And I've got two x terms, so I don't want to go this way. I would go this route. My equation is in standard form, so I'd go this route and then start off by calculating that discriminant. Calculating the discriminant, you have b squared minus 4ac simplifies to 4. 4 is a perfect square, so we can factor using two binomials. So x minus 5 and then x minus 3. If I were to FOIL that, so first times the first, and then the outside 2 and the inside 2, and the last 2, you'd get back to this trinomial. And then you just solve each binomial set equal to 0. So adding 5, one value for x is x equals 5. And then adding 3, one value for x is x equals 3. So it definitely helps to have your flow chart out to follow along to determine what the best method is when you have to answer those types of questions. But for actually solving, use the method that's going to work best for you. So some of these are definitely easier for factoring. So like this method, if you can recognize how it would factor right away, you can skip the binomial or the discriminant part. But if you can't recognize, certainly calculate that discriminant first to see if it's a perfect square. If it is a perfect square, then factoring would be your right answer. Not a perfect square, then you'd want to use the quadratic formula.